In this video, we're going to demonstrate a road realignment project. For it, we're going to use a couple different data sources. Our preliminary alignment is going to come from a shapefile. The majority of our topo is going to come from DEM LiDAR, and our conventional survey data, we're going to use a little bit here up in the north of the project. Okay, let's jump into it. We're going to be using RoadEng, an easy-to-use road and site design software. The program is modular, so we're going to start here in the terrain module to create our surface and then move over to the location module to do our design. Opening up here, first couple pieces of data. This is our shapefile, and then we're going to import our LiDAR tiles. We're going to use our shapefile feature to thin our LiDAR data. We do this here on the selection tab, add that as a corridor filtering region, and this way all of the data outside of this corridor will be brought in at a lower resolution, and all the data around that corridor feature is going to be brought in at full resolution. So this helps us just keep our point count and our file a lot more manageable. Okay, while our LiDAR processes for import, let's open up another terrain here and import our total station. Now RoadEng, it gives you the ability to customize your import and reuse those settings through something we call an IOP. So we're able to do that as well. We're also able to set our coordinate, and we're going to do this so we are in the same coordinate system as our other data. Now that we've imported the total station data, let's generate a surface. So we can generate our DTM. If we wanted to, this is also the point where we could have added contours, a whole bunch of functions and features up in that dialog that we kind of skipped over. But yeah, basic DTM looks pretty good. Let's save it. Now, before we move on, we're going to just bring in a background ortho photo from our Live Maps feature. So this allows us to get some web-based imagery, either from Google, Bing, or MapTiler. It is literally as simple as cropping the image to the area we want, and we're going to include the rest of our sort of data set that's covered by our LiDAR here, adjusting the resolution, hitting save, and then that image is actually brought in automatically geo-referenced into the background. Back in our other terrain window, our LiDAR data has finished importing. Let's go again and create our DTM. We again don't care about contours, so I'm going to deselect those. And now let's bring in that total station data so we can reference that through merging terrains. Quick recap on what we've done so far. We've brought in a shapefile, we've imported a LiDAR tile, and we have imported a total station file, and we've now merged them all together in the same file. That background image that we were downloading has finished it. Let's go ahead and bring that in as well. Okay, just making a few changes to our merge options, and now let's go ahead and model it again. This time, let's select our contours. We can control the intervals as well as the labeling, the start contour elevation and the end contour elevation. Lots of functionality and capabilities there. This feels like the perfect time to mention it. We like to keep our videos all in real time, so everything you're watching here is being done in real time. And yes, sometimes it can take a few seconds to load contours and to generate tins, especially when we're dealing with larger data sets. Okay, let's save our new combined topo file and switch over to the location module. Okay, as we mentioned before, this is a modular program. So we're going to start our new location file and reference that topo file that we just created. With our topo in the background, we're just going to bring that same image that we downloaded as an ortho photo back into the background here of our location design. Okay, now it's time to add in our horizontal alignment, and this is really what makes RoadEng. What you're going to see here, we're using the Add Edit IP tool, and we are literally just clicking in our plan window. So what we're really trying to show here in this quick video is the ease of use as well as the dynamic interactivity that RoadEng gives you for designing. We are approximately 4.5 minutes into our design. We've got a horizontal alignment almost finished here, and we're ready to add some curves. So over here in our curve panel, we have the ability to apply our default curve against all of the IP points. So that one here, we've got it set up for a default curve, I believe, of about 80 kilometers per hour. We can go through and fine tune each individual curve afterwards, but it gives us that ability to quickly apply our default design speed across the entire horizontal alignment. RoadEng is compliant with TAC and AASHTO standards and has an ability to import your own local government standards if you're not working here within North America. So here I will just show you how we can quickly flip through a couple of the IP points, adjusting the curve here, and watch what happens in both the cross-section and the profile window. So these are dynamically updating as we move through our design. Moving over to our vertical alignment, same at Edit IP tool. We're literally going to click in our IP points for our profile, and you'll see that same dynamic updating across all the windows. At the bottom of the profile window, you've got your mass haul graph to help you visualize your materials, and there's a whole bunch of other additional material movement factors as well as ground types that you can bring into the software. But for the point of keeping this introductory video simple, we are going to skip past those. Okay, similar to our horizontal curve panel, we have a vertical curve panel as well. This allows us to apply various curves to our vertical alignment, easily applying our default curve with a design speed and moving through it. Same automatic updating, it's all in real time. Zooming in a little bit here to our profile window, you can see that we have grade labels displayed, and we can make adjustments to those IP points in order to bring down grades if you've got a certain minimum or maximum you need to work with. Adding a few more curves to our vertical alignment. Our plan and our profile, so our horizontal and our vertical alignments, are connected, and we control their geometry through a cross-section template. So let's take a look at that in a little bit more detail. Opening up our cross-section editor, this contains all the different building blocks for your template. Now, our flexible template editor allows you to assemble typical sections using a library of customizable components. Each of those components essentially has items in it that allow you to count for ditches, pavement, sub-base materials, varying lane widths, cut slopes, variable height, fill slopes, curbs, sidewalks, etc. Just to keep this example simple, we're not going to change our template, but just wanted to open it up and show you. Using an Assign by Range tool, we can assign different cross-section templates to different parts of our design. Okay, so in this particular section of our design here, we need to add in a bridge template. And we've made note before this video was filmed of a few different sections of our design which we were likely going to need to add a barrier alongside our road template. So we can use our Assign Parameters by Range dialog. We can select our different template names and the station ranges to which they apply. Using the Add Edit tool, we can apply those ranges to either the left side, the right side, or both sides of our cross-section template. It's worth mentioning while we're in here, the Assign Parameters by Range has applicability to other things beyond templates. We can work with fill types, subhorizons or our ground types, site prep, overrides, and then at a specific station we have the ability to add borrow and waste pits. So all of these things can be assigned by range, and that's done here. Now that we're finished adding in our different templates by range, we can go and recalculate our alignment. Notice that we checked our recost box, and that's going to allow us to get a cost for our alignment. RoadEng allows you to calculate your costs as you design. The costs are controlled by your ground types, and there is a costing table that's associated with all the different ground types. We also have an ability to assign haul costs or your transportation costs. All of these factors are configurable. And even if you don't know your specific costs, they can be used to compare alignments as a rough approximation. You can see the total cost for your design over here in the Project Explorer panel. The last thing we're going to take a look at in this quick introductory video is Multiplot, and that's where we make our construction output sheets. You can easily share and showcase your design with Multiplot Report Builder. Print out plan, profile, cross-section data all as one document. The output sheets interactively update with your design. You can also easily output and share with other programs. RoadEng can integrate into other CAD or GIS-based engineering systems, and you can easily export to machine control through LandXML. And that's it for this quick intro. Check out our YouTube page for more videos on RoadEng.